Hey guys, in this video I am going to show you a trick how to find the hybridization of any molecule in just 5 seconds. The best part about the trick is that you don't need to mug up any formula regarding hybridization. You just need to know how to calculate valence electrons of central metal atom or central atom, and you just need to remember a basic table involving steric number and hybridization. So let's see the steps of this trick. The first step is to count the valence electrons of central atom. This means, first of all, you just need to identify which is the central atom in a molecule. For example, in PCl₅ phosphorus pentachloride, the central metal is phosphorus, and then you just need to calculate the valence electrons of phosphorus, and then you proceed to the next step. The next step is that only sigma bonds are counted. This means if you find any pi bond, then you just need to exclude that pi bond in calculating the steric number. And then the next step is count lone pairs. This means if any lone pairs are there, you need to count it for the steric number. And the last step is steric number is a summation of sigma bond and lone pair. You just need to remember what is steric number. It is a summation of sigma bond and lone pair. And you need to remember this table also. This is the most important table. Without this table you will not be able to find out the hybridization. So for steric number 2 we have the hybridization sp. For 3 it is sp2. For 4 it is sp3. For 5 it is sp3d. For 6 it is sp3d2, and for 7 it is sp3d3. So now let's see how this trick works using an example. So the first molecule that is given to us is NH3, which is also called ammonia. So in NH3, nitrogen is the central atom. We know that valency or valence electrons. We know that the valence electrons of nitrogen is 5, since nitrogen belongs to group 15 of the periodic table. And after finding the valence electrons, you can draw a structure, basic structure involving the central atom, and then you can also represent the valence electrons in the form of dots, or you can directly find the hybridization using the trick. But I recommend you to draw the structure first, because that will help you to know the next step or to use the trick more efficiently, or you will not do any error in the trick if you follow the structure. So first of all we draw the structure. We need just the central metal, that is nitrogen, the central atom. So we represent the valence electrons in the form of dots. So the valence electrons are 5. Since the valence electrons are 5, so we represent these valence electrons in the form of dots. So 5 dots are there, and there are 3 hydrogen atoms. So 3 valence electrons are used up in forming the bonds. So there are 3 hydrogen bonds and 1 lone pair. Since there are 2 unpaired electrons, so these 2 unpaired electrons constitute a lone pair. So that is there are 3 sigma bonds and 1 lone pair. So steric number is equal to steric number is the summation of sigma bond and lone pair. You already know that. So since there are 3 sigma bonds and 1 lone pair, so the steric number is 4. And for the fourth steric number we have the hybridization, that is sp3. So sp3 is the hybridization. Now let's see the next example, that is PCl₅, which is also called phosphorus pentachloride. So we know that phosphorus has 5 valence electrons since it belongs to group number 15. So therefore its valence electrons are 5. This is a simple formula. So phosphorus has 5 valence electrons, that is 1, 2, 3, 4, 5, and there are 5 chlorine atoms. So each chlorine atom makes bond with each valence electron. So there are 5 valence electrons, so 5 chlorine atoms are there in the bonds. So 5 valence electrons are used up in making bonds. So here steric number is 5, and for the fifth one we have sp3d as the hybridization. So the hybridization is sp3d. So you can see that this is a very simple trick, and if you practice this trick regularly, then you will be able to crack any hybridization problem within a second. So let's see the next one, which is a bit complex, that is chlorine trifluoride. This one is very important. So we know that chlorine belongs to group 17 of the periodic table. So chlorine has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. And there are 3 fluorine atoms. So 3 valence electrons are used up. And there are 4 valence electrons remaining. So these 4 valence electrons constitute 2 lone pairs. So one lone pair here, another lone pair here. So there are 2 lone pairs. So steric number of sigma bonds 1, 2, 3, and there are 2 lone pairs. So steric number 5. So that is for the fifth one we have sp3d. So the hybridization is sp3d. So this is a trick basically. And we have the last example as xenon tetrafluoride, that is XeF₄, and this is the most important example. I guess you may have practiced it during the preparation of JEE and NEET. This problem can, or this example can come in the exam. So we know that xenon belongs to group 18 since it is a noble gas. So it has 8 valence electrons. 1, 2, 3, 4, 5, 6, 7, 8. And you have 4 fluorine atoms. So 4 valence electrons will be used up in making bonds, and we have 4 remaining valence electrons, and this will make, or this will lead to the formation of 2 lone pairs. So there are 2 lone pairs and 4 sigma bonds. So we have the steric number as 1, 2, 3, 4, 4 sigma bonds and 2 lone pairs, that is 6. And for the steric number 6 we have the hybridization is sp3d2. So sp3d2 is the hybridization. So this is all about the trick.